Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. Most of the examples on one-tailed tests also provided in this playlist focus on positive effects. So in this video, let's do something different and let's test a coefficient is negative using the p-value approach so that we can finally put together all of the elements that were mentioned also in the previous video on the discussion whether we should be running a one-sided test or a two-sided test. Let's assume that the economic question that we are trying to answer is higher taxes reduce hours worked. So we are specifically interested in a negative effect. So this direction is chosen before seeing the data. Then we will collect some data. We will have some estimations which are written in here. So we're going to assume that the estimated coefficient is 1.6, standard error 1, and the sample size 40. Now we're going to have to make to come to a conclusion based on what we observe through the data. Starting from the usual steps that we have now been practicing throughout all of the previous example videos, we're going to state the null hypothesis, where we can write this as beta being greater or equal to 0. And the alternative hypothesis, where we're going to write beta is smaller than 0. Okay, one-tailed negative. So because the alternative is directional, so this is a left-tailed test, okay? The next step would be to use the information that we are given in here so that we can really assess whether this estimate is sufficiently negative. And the next step would be computing the t-statistic, so our t-star, which according to the formula that we have seen so far is minus 1.6 minus 0 divided by the standard error, which are 1, which will give us a minus 1.6. And we also know that this t-star under the null should be distributed under a t-distribution of n minus k minus 1, assuming we just have a simple regression in here. We'll just say this is n minus 2, where the n is the 40. Okay, so at this stage, where we have the t-star in here, we're saying that the estimate lies 1.6 standard deviations below 0. So we're just looking at a distance, but in the negative direction. So once we know that we have to look at a t-statistic from the t-distribution with 38 degrees of freedom here, we also have to pick a significance level that we might want. Let's always stick for now to the 5%. So normally the interpretation that we would be looking for, so this is our t distribution, this is where 0 is, and then as I said, this is where minus 1 would have been, so 1 standard deviation. This is where minus 2 would be, and our t-star is minus 1.6, which is right here. So this is the t-star. We're looking to see whether that's like extreme or not, okay? Now, for a left-tailed test, the p-value is the probability of observing a t-statistic less than or equal to the minus 1.6 if the null hypotheses were true. So visually, it is the area that it's on the left tail beyond minus 1.6. So if you remember, the t-distribution is symmetric. which means that the same way we looked for positive values and we found that anything extreme on those cases was beyond in this area right here, then symmetrically, if we mirror that process, it means that, well, now we're looking at extreme values beyond here. And this area would have been identical to the area that we would have found if this was a positive direction on the 1.6, okay? So using the table or a software, you can find that the probability of you finding a t-value that is smaller or equal to 1.6 is approximately 0.06. And that means that your p-value, so your p-value is approximately 6%. So that is 0.06. When we make the decision, we have to compare the p-value that we found, so this is our p star, to the critical, like alpha significance level that we had chosen. In our case, the p star value that we found, which is just the 0.06, is actually bigger than the 0.05, which was the alpha, the significance level that we chose. So given this, it means our decision is we fail to reject the null hypothesis. Now, failing to reject the null hypothesis means that, well, the estimate is negative, but not negative enough. So not negative enough to rule out randomness. Okay? Which means that the data seems more compatible with like a zero effect or maybe even slightly positive effect. But keep in mind, this is not a contradiction per se. It just reflects the uncertainty related with our data. Now, again, why direction matters here. We only looked at the left tail. So a positive statistic would never lead to a rejection, and that's because the question itself was directional. So this is also why the tail choice must be made before looking at the data. In a one-tailed p-value test, keep in mind, extremeness is measured only in the direction specified by that alternative. I hope this video was helpful, as now you would have seen a one-tailed and two-tailed test, the critical value and the p-value approaches, and positive and finally negative direction. So all of these together should give you a very clear view of all of the possible scenarios you could be asked to go through when doing hypothesis testing. Thank you for following this video, and I'll see you in the next one.